Okay, good morning everyone and happy Friday. We are going to be looking at the second half of Lesson 53 today. So if you have your packets, go ahead and make sure that you're on the page for Lesson 53. We did the first part of it today in class, and actually you're watching this on Friday. I'm videotaping this on Thursday, so I'll say that we did the first part of 53 yesterday. Okay, but I'm not sure. I cannot remember, and I don't think we did. If we did this, you can skip past this, but I'm going to go ahead and work the problems out for the practice set. So if you have your books and you haven't done this, you can turn there now, and we will go ahead and work these problems out, A and B. And this will just be a little review for what we did do in the first half of 53. So we're going to simplify this pretty big problem. I say pretty big. It's really not that big. It's going to take us just a couple steps to get through it. It just looks big when you look at it. So I'm copying it down here now over x cubed. So let's go ahead and work this out. So if you remember from the lesson that we went over in class on Thursday, we learned that when you have an exponent on the outside of a parenthesis, it's going to affect every exponent on the inside. Remember that what this actually means is that all of what's inside here is being raised to the negative third power. So we talked about how to handle that in class, and we're going to go ahead and do that now. So I'm going to keep this in orange for now. So remember we said that if you have an exponent on the outside of your parenthesis like this, you take it and you multiply it with every exponent that's on the inside of your parenthesis here, including any exponents that are sitting in the denominator as well. So if we do that here, we would have 3 to the 0 power, because negative 3 times 0 is 0. Now we take negative 3 and we multiply it with this negative 2 over here, and you get a positive 6, and z to the negative 15th power. And on the bottom, we would have x to the negative 9th power. Now, in the problem, it says that they want all variables in the numerators, which means then we're going to have to do a little bit of adjusting here to get everything into the numerator. The only thing that really needs to be moved upstairs is this guy. So we would end up with 3 to the 0 power. Whoops, actually, I'm not even going to rewrite that, because remember what this really is just 1. So we would have, and I'm going to write the variables in order. So we'd have x, y, and z. So we have x to the 9th, y to the 6th, and z to the negative 15th. Because remember, when we move the x term up top, the sign on the exponent changes from negative to positive. Anytime we move a term with a exponent upstairs or downstairs, the sign on that exponent will always change. So there's the answer to letter A. Now let's look at letter B. Now letter B really is a little bit more of a doozy, so I'm going to actually start it up here so that I'm sure I don't run out of room. It's x squared y to the negative 2nd power, and you can be writing this down as well from your book. 3m to the 4th power times k, and all of that is raised to the negative 2nd power. And then the next one that's being multiplied with that is y to the negative 2nd power times m over x to the 3rd power times k, and all of that is being raised to the 2nd power. Okay, so we're going to handle this one exactly like we just did the problem to the left. We're going to take the exponent out here of negative 2 and multiply it with every exponent on the inside, including those that are in the denominator. I'm sorry, did that make your eyes batty? It did mine. Okay, so let's handle what I just drew arrows to. So we would have x to the negative 4th power times y to the 4th power over, remember, we're just going to multiply. Now remember, there's a 1, an exponent of 1 on that 3. So you need to make sure that you multiply, because the 3 is a term that's inside the parentheses that needs to have the negative 2 multiplied with its exponent. So we would have 3 to the negative 2nd power, m to the negative 8th power, and k to the negative 2nd power. excuse me, we're going to do the same thing over here. We're going to take this positive 2 exponent and multiply it with every exponent on the inside. You might have to put a 1 there with our m so you know what you're multiplying. So we have y to the negative 4th power, m to the 2nd power. And we multiply it with exponents in the denominator as well. So we have x to the 6th power times k to the 2nd power. Okay, so that's multiplying all of that. Now that eliminates our exponent on the outside, so we don't have to worry about handling any of that concept in the rest of this problem. But what we do need to do is get all of our exponents in the numerator. So we're going to take a moment to do that. I'm going to change the color of my pen back to blue. And I'm going to take all of these and move them upstairs, and all of these and move them upstairs. So let's go ahead and do that. We'd have 3. And remember what happens when I move any exponent upstairs or downstairs, the sign on that exponent is going to change. So 3 to the negative 2nd power, when I move him upstairs, will become 3 squared. M to the 8th, k to the 2nd, x to the negative 4th, because that's already up there. I'm going to put that in parentheses. And then we're going to move all of what's, and actually I'm just going to go ahead and write what's up there already and leave that there. Now we're going to move the terms in the denominator, we're going to move them upstairs. So we have x to the negative 6th, k to the negative 2nd. Okay, now what we want to do is combine any like terms. So we're going to have to multiply, because that's what this problem is. It's a multiplication problem. So the first thing I'm going to do, I'm going to change my pen back to green, and we're going to take care of this 3 squared. We're going to go ahead and put we're going to go ahead and put 9 here. The next thing I want to do is I'm going to try to get my terms together, and I'm going to try to keep them in order. So x would be the first term that would be in order. So I'm going to have to take care of those two, but I'm going to write them side by side because I want us to be able to see those. So there's my x's. The next one I'm going to use is my k, so I'll put these in alphabetical order. So I'd have k squared times k to the negative 2nd power. M would come next. I have m to the 8th power times m to the 2nd power. And then finally, our y terms. I have y to the 4th times y to the negative 4th. And I did that because I wanted you to be able to see those together. It's a little bit easier to keep track when you've done that. So now I have 9, and what am I going to do with these exponents now? It's not like the ones up top. They're not on the outside of any parenthesis, so we don't multiply our exponents now. Now we're going to add our exponents when we put these together. So we're going to have x to the negative 10th, k to the 0, m to the 10th, and y to the 0. And we know what happens to these guys, right? They're just 1. So our final answer would be 9x to the negative 10th power times m to the 10th power. That is the final answer for B. So hopefully you were able to work that out as well. Okay, so let's go ahead and move on to the concept for today. For 53B, we're going to be talking about conversions of volume. I'm going to go grab another sheet of paper here because I want to do a couple examples that you do not need to write down. Okay, so we're going to be talking about conversions of volume. So when you think of volume, you think of something that's cubed, right? So because that's length times width times height. So there's 3 measurements we're multiplying. So if we were multiplying inches, it would be cubed because of the 3 measurements. Okay, so when we're talking about volume, that's what we're talking about. Now I'm going to erase that off here just to get it out of the way. Okay, so let's look at a problem together I want to do for you. This is not in your notes. I really just want you to kind of watch how this is handled. Okay, so let's say you have a problem that tells you to do this. Let's use 3 unit multipliers. Hopefully that's a familiar term to you because we've done unit multipliers for a couple years now. To convert 180 feet cubed to cubic inches. Okay, so we're in the customary system. We're staying with feet cubic feet to cubic inches. So it's not like we're going from the metric system to the customary system. So that's kind of nice. But we're going to see a problem like that in just a few minutes. So remember, we always start with what we're given. So we have 180 feet cubed. My recommendation is that you write it like this. Write the 3 feet here, because when you do your canceling, it's just kind of a nice systematic approach. So we write what we're starting with. What are we trying to convert, and what are we going to convert to? Well, first of all, we're going to use 3 unit multipliers to make the conversion. So I'm going to go ahead and build those in, and we'll go ahead and fill them in. Now we know if we have 3 feet up here, then we're going to have 3 feet on the bottom here, because that's what we are looking to cancel out. We're also trying to get to inches. So our conversion, our unit multiplier, is going to be 1 foot to 12 inches. 1 foot to 12 inches, and we write that all 3 times. And watch what we're going to do. We can cancel the 3 feet. 1, 2, 3, 1, 2, 3. What I like to do is I like to circle what is left so I don't miss a thing. So I have 180, I have 3 12s, and I have 3 inches. And that's perfect because we were trying to get to inches. So my final answer here would be 180. There's nothing in the denominator. We have 12, 3 of those. So we can just write 12 to the 3rd power inches cubed. Saxon says we can leave it right there. We don't even have to take the calculator to expand that out into a final answer. This can be used as our final answer. Okay, so hopefully that didn't seem too bad. Now let's do the next one. The next one's going to be a little bit trickier. So we're going to use 6 unit multipliers on the next one. I'm going to abbreviate multipliers here. To convert, let me put a line here so we can get that out of the way. 800 cubic centimeters to cubic feet. Okay, so we're going from the metric system here to the customary system. So we're going to have to make more than one conversion, which is why they want you to use 6 unit multipliers. So let's write down first what we're starting with. What are we trying to convert? We're trying to convert 800 cubic centimeters. And since it's cubic centimeters, that means it's going to be, I don't even have to write the word cubic. We're just going to put centimeter times centimeter times centimeter. That represents cubic centimeters because it's centimeters multiplied 3 times with itself. Okay, so that's what we're starting with. I'm going to build in 6 unit multipliers if I can fit them all. Okay, alrighty. So I know that centimeters is going to have to go on the bottom here. Why do I know that? Because I'm going to want to cancel these 3 out. Okay, so I'm trying to get to feet. That's what I'm trying to convert to. So I know the end unit is going to be feet. So I don't want to put feet right here in these first 3 unit multipliers. But we do have one that we know pretty well. We know that 1 inch is 2.54. That's something that we will memorize if you haven't done so already. That's a common one that we use for a conversion. So 1 inch equals 2.54. Okay, and I'm kind of skipping over what the unit multipliers are all about because I think you guys remember that when we use a unit multiplier, all as it really means, remember this whole unit multiplier here really equals 1, doesn't it? Because 1 inch and 2.54 centimeters are the same exact measurement. That's why it's kind of nice because you're actually multiplying with the number 1 all the way across here. You're just writing it in a different expression. Okay, that being said, we can cancel out those 3 centimeters now. Okay, now the next conversion has to have inches on the bottom, remember, because we are trying to do some cross-canceling. We can cancel these 3 inches out as well. So if we're trying to get to feet in the end, then that must mean that feet is going to be on the top here. So 1 foot is equal to 12 inches. We write that on all 3. And we can cross out those 3 inches on the bottom. Now let's go back and circle all that we're left with. I'm going to use a green color here so we don't miss anything. I don't circle the ones because I don't really need to, but I am going to circle the feet because that's important to remember. And all of these 2.54s on the bottom and these 12s. So my final answer here is going to be 800. I just write down everything that's left. Nothing else on the top. I have 2.54 cubed on the bottom times 12 cubed on the bottom, feet cubed, and that's your final answer. Okay, not so bad. That's the concept. Now let's go ahead and try one of these in our notes. I'm going to skip over to the notes section now. Sit tight till I get there. Okay, just looking because I'm not sure. It looks like we're not video taping anymore or recording. I hope we are. I'm going to keep talking. Okay, so let's go to our notes right here. It's on the back. You'll have to flip the page over to get to the volume section here. And if you don't mind, I'm going to go ahead and just erase all of this. You should already have that into your notes now. I'm erasing it because I need that space up here. Okay, so we're going to use 3-unit multipliers. I'm looking at number 5 here. 3-unit multipliers to convert 30 cubic yards into cubic feet. 3-unit multipliers. So we always write first what we're starting with. What are we converting from? So we're taking 30 cubic feet. So we're going to write feet 3 times and multiply them. 3-unit multipliers. So let's go ahead and build those in. Trying to get to feet. Oops, goodness gracious. I'm sorry, guys. Hopefully you're sitting there, I'm sure Bailey is, telling me, wait, Miss Quigley, that should be yards. You're so right. There we go. Okay, so let's fix this now. Our unit multipliers then, yards are going to be on the bottom, right? Because I want to go boom, 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 boom. Okay, so if we're ending, we're trying to get to feet. So 1 yard is 3 feet. So that's what we fill in here. Now let's circle what we have. 30, 3, 3, 3, and all these little feet. So the final answer here would be 30 times 3 cubed feet cubed. And that's your final answer right there. Okay, so make sure that's built into your notes. Let's go ahead and work out the practice problems for C and D, and then you can be free to work on your lesson problems. So let's look at C. If you're still on page 216, it's at the bottom. I'm going to go with black now. C, we're going to use 3-unit multipliers to convert 75 cubic inches to cubic centimeters. So we're starting with 75 cubic inches. So we're going to go inch times inch times inch. And 3-unit multipliers, let's go ahead and build them in. Okay, and we're going from inches to cubic centimeters. Okay, so here we go. We're going from the customary system in this one, from inches to centimeters, into the metric system. So our conversion, our unit multiplier here needs to be the centimeters and inches, because that's the one that we can kind of memorize. 1 inch is 2.54 centimeters. So this works out pretty nicely here. Let's circle what is left. Oh, let me go back and go inch, 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 inch. We can cancel those 3 out. Now let's go in there and circle what's left. Centimeters, 2.54 centimeters. And that's what's left, which is perfect because we wanted to go from inches, cubic inches to cubic centimeters. So our final answer is going to be 75 times 2.54 cubed centimeters cubed. And that is the answer for letter C. Now, if you'd like to pause the video and try D on your own and then come back and check the answer, see if you got it right. If not, then you can watch me do the steps. Otherwise, then you can move right on. So go ahead and pause the video and try letter D by yourself and then come back and check it. Okay, so letter D says we're going to use 6-unit multipliers this time to convert 28 cubic meters. 28 cubic meters, so meters times meters times meters. 6-unit multipliers, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. And we're going to cubic inches. So we want to end with inches. So the first thing we have to do is make a conversion in our metric system. We know about the one that's meters to inches. We know that 1 inch is 2.54 centimeters, but we can't use that one because we have 6 unit multipliers. So that's going to be the one in the end. So what I need to do, though, is I need to go from meters to centimeters. If you forget how many centimeters are in a meter, remember the little trick that we used before? King Hector died by drinking chocolate milk. And this is always your basic measurement here. So in this case, it's meters. So if I'm going from 1 meter, I put my 1 here, and over here centimeters. How many zeros does it take to get over there? 2. So 1 meter is equal to 100 centimeters. Remember that little trick we've done in the past? I'm going to erase it to get it out of the way. All right, now I can take my meters, 1, 2, 3, and cancel those out. Now I'm going to have centimeters on the bottom here so that I can cancel those out. And I can make my conversion here from centimeters to inches because that's where we want to land. So we have 2.54 centimeters equals 1 inch. We're going to write that on all 3 of these. We'll cancel out our centimeters, 1, 2, 3, 4, 5, 6. And we're going to go back and circle what is left. We have successfully landed with inches, and that's what we wanted. We have a 28 over here, 3 100ths. I'm not going to write down any of the ones, but I do want to circle the inches because that's where we wanted to land. We have 2.54 3 times. So our answer is going to be written like this: 28 times 100 to the 3rd power, or cubed, over 2.54 cubed inches cubed, and that's the answer to letter D. Okay, so you can go ahead now and work on the problems. You shouldn't have too many left because on Thursday you guys probably worked out a good many of them. And I think there was only one from the second part of this lesson in the lesson set, or practice set, so you'll probably get this done pretty quickly. Remember that there's a window of time that you can meet me on the Zoom call. If you have any questions from lesson 53 or even anything before that, I do think you turned in everything up until that point, so you probably don't have any other questions from any previous lessons. So I guess we'll call it a day here. If I see you in the Zoom call, that will be great. Please feel free to pop on at any time. We will have on Tuesday, we'll be looking at lesson 54, and on Thursday, we'll be having a test that will be testing you on all the concepts up through lesson 48, I believe. Please remember that on Tuesday, this lesson 53 will be due to be turned in. We will check those answers. If you want to hop on the Zoom call to check your answers, that might be a good idea. And then if there's any you got wrong that you have questions on, we can cover those in the Zoom call sometime between 10 and 12. All right, everyone, have a wonderful day, and thanks so much.